Hey YouTube, welcome to what will probably be the last remote control mower design concepts video. In this video I'll be looking at the physics of the mechanical linkages and how they interact with one another. But before we begin we need to cover off Newton's third law of motion, which you might simply know it as. Now you might be thinking, how is this going to affect mower design? Well, because as the mower moves forward, an equal force is trying to push the deck backwards. And without some form of restraint, the deck is going to move backwards like this. Using a link bar as shown can prevent the backwards movement, but it has to be well designed or otherwise it can still move around. Designs that are tied to the deck at several locations can help stop rotational movement. Alternatively, adding a second set of link bars can be a very effective way of controlling movement. In conjunction with the frame, it forms a box and boxes it in, giving it its strength. All of the link bars need to be exactly the same length from centre to centre to prevent binding. Otherwise, the lifting motion could be jerky and potentially wear parts out, especially around the holes and the bolts that go through them. This is more than likely a software glitch, but this is what binding would look like in the real world. You can see how the parts are being strained. By raising the lift arms precisely 100 millimeters, the problem went away, indicating that the problem is in the software. But it does highlight the next problem that I wanted to show you, which is what happens when you go over center. Now in the software it will allow you to go over center and it'll allow you to come back. In the real world this wouldn't happen like this. It would either catch on the bolts or the sheer weight of it would stop it from coming back. The next thing I want to look at is arm length and the effect it has on the deck movement forwards and backwards. The shorter the arm, the more it'll travel in an arc and the further it'll move backwards and forwards. In this example I have two parallel lines which are 50 millimeters apart to indicate the travel in one direction. The distance from the pivot to the hole is 150 millimeters and the second hole is 75 millimeters, exactly half the length. But the angle of rotation is more than doubled. The more the arms rotate, the better chance they have of binding up or catching on something. And the further the deck moves, the more chance it has of hitting something. There are practical limits, but this is one of those cases where bigger is actually better. Well, that's it for this video. There was a lot of work went into making this one, so if you can, please give me a like. And thanks for watching.